Okay, let's get into this. The source material we have today is just a fantastic example of what happens when a true hobbyist goes all in.
It really is.
We're talking about a blog post titled Notes on Gardening, Part 756, by a guy who calls himself, and I love this, an old software plumber named Ang.
And that number, 756, that tells you everything you need to know right up front. I mean, that's not just a hobby, that's a discipline.
Discipline is the perfect word for it. So our mission today is to follow Ang's trail here. We're going to break down his insights, specifically about his recent rediscovery of this really striking purple plant.
The red ivy, or Strobilanthes alternata.
That's the one. We're going to look at why it was giving him trouble and how that led him to compare it to a sort of sibling plant. It's a great story of troubleshooting.
It's a perfect case study in how systems thinking, the kind of logic you need for Python or Haskell, translates directly into something like horticulture. He's looking for patterns, for variables.
Okay, so let's start where he did. The red ivy, Strobilanthes alternata. Ang says he'd seen it 1,000,000 times. It's used everywhere in roadside landscaping.
It's one of those plants that's so common it becomes invisible, like background noise in the garden.
Exactly. Like a utility function you call every day, but never actually look at the source code.
Yeah.
But something finally made him stop and take a closer look.
And it was the foliage. It had to be. This plant has this really unique, almost metallic or silvery sheen to its leaves.
Yeah, he says it catches the light in this very specific way. It's not just purple, it's reflective. It's a variable that just, it demands your attention.
And this is where it gets interesting with the naming. He mentions a local name, Bernatu Api.
Right, but he puts this very careful note in there. He says that name is unverified.
And that it was suggested by an AI, which is such a modern detail.
It's so perfect for a software guy, right? You run a quick query, the AI gives you a plausible but unconfirmed string. Bernatu Api, the good starting point.
It's a starting point, but it's not the verifiable truth. For someone like Ang, that's not enough. He needs the scientific name, the Strobilanthes alternata, because that's the key to unlocking all the real documentation.
That's the verifiable data. So he's got the plant, he's got the name, he's got this cool metallic sheen. But the actual deep dive, the reason we're talking about Part 756, didn't start because the plant was doing great.
Of course not. The deep dive always starts with a bug report. A failure.
Yes, the debugging process. He noticed the growth in his garden was uneven, patchy.
So some plants were thriving, others were just gone, bare spots. It wasn't establishing uniformly.
And this is where that systems thinking really kicks in. A troubleshooter like Ang sees patchiness and immediately thinks, okay, a variable is off somewhere.
He started with the basics, right? The main system requirement.
Yep. He knew the species needs bright, indirect, or filtered light. That's the baseline. Too much direct sun, the leaves scorch, not enough light.
And you lose that amazing purple color. It just turns a sort of sad green.
But, and this is the critical part, he didn't just stop there. He didn't just say, oh, must be the light and move on.
No, because a good programmer knows it's rarely the top-level issue. You have to look at the dependencies, the environment itself.
So he started brainstorming other causes for the patchy failure. And he landed on two main possibilities beyond sunlight. First one was potential nutrient imbalances in the soil.
Which is, that's the ultimate state management problem for a gardener, isn't it?
How so?
Well, it's never just one thing. It's this messy, complex interaction of pH, bioavailability, different nutrients competing with each other. The data is, it's just unreliable without lab tests.
A cascading failure, as opposed to his second theory, which was much simpler.
Mechanical failure.
Right. He thought, well, maybe some of the plants just didn't survive being transplanted in the first place.
Transplant shock. It's basically an initialization error. The program never launched correctly. If the roots don't establish, the plant just fails.
And that's a much cleaner variable to isolate, isn't it? It's either transplant shock or it's this incredibly complex soil chemistry problem.
Exactly. Is it a problem with the initial setup, or is it a persistent, ongoing environmental issue? That's the core of his diagnostic process. It's the stack trace for your garden bed.
I love that, the stack trace for the garden. And it's that approach, seeing failure as a data point, that really sets his work apart. This whole process eventually made him think of another similar plant.
A close relative, yeah. It triggered a memory.
The sibling species, the royal purple plant, Strobilanthes diariana.
And he mentions he'd written about this one before, way, way back in Part 557.
Which is just an amazing callback. The sheer depth of his documentation is incredible.
It shows he isn't just solving a problem in the moment. He's building on a huge personal knowledge base. He's connecting this new bug report to an old file.
He mentioned that his fascination with plants like coleus, plants known for their wild foliage, is what drove him to want to be really precise here.
He needed to know for sure. Am I dealing with a struggling alternata? Or did I maybe misidentify it? Could it be a diariana that's having issues? For him, ambiguity is the enemy.
Especially for someone who works with things like Haskell. I mean, data purity is everything. So he needs a clear, documented distinction.
So it goes back to his toolkit.
Back to the AI. He used it to generate a direct side-by-side comparison, a visual diff, if you will.
And that's where he gets his aha moment, the definitive answer. Because when you put them side by side, the key difference is actually pretty simple.
It all comes down to the leaf shape.
Just the leaf shape. It's the kind of thing you'd see in a field guide.
So for Strobilanthes diariana, the royal purple plant, the leaves are described as distinctly long and pointed.
Right, almost like a spearhead, lance-shaped.
Whereas the red ivy, the alternata he was working with, has leaves that are
Noticeably rounder, more of an oval. And that's it. That's the clean binary distinction he was looking for.
long and pointed versus round.
It's the perfect identifier. If you're standing there in a garden center looking at two very similar purple plants, that one detail tells you everything. You know which care instructions to follow.
It connects the big, abstract botanical science right down to the practical application. For him, it's about getting the input parameters right so the function can execute properly.
Exactly. And that level of precision, it tells you so much about his mindset. It's not just about keeping a plant alive. It's about understanding the system so well that the plant can thrive and express its most unique features.
Okay, so that brings us to the bigger picture here, the takeaways. Let's break down what we've learned from Eng's notes.
Well, for one, we have a clear, practical identifier. The round leaves of the red ivy, S. alternata, versus the long, pointed leaves of the royal purple plant, S. styriana.
And we know the key to growing that red ivy is filtered light, and that if it fails, you have to debug it like software, isolate the variables. Was it transplant shock or a soil issue?
But the real insight here, the thing for you to really think about, isn't really about purple plants at all, is it?
No. It's about how skills transfer from one domain to another. Think about Eng's day job, this old software plumber.
He deals in logic, in systems, in verifiable inputs and outputs. Functional programming is all about managing state in a very explicit, documented way.
And he applies that exact same rigor to everything. He mentions his other hobbies, fish keeping, photography.
And you just know he's not just, tossing flakes in a tank. He's meticulously documenting the nitrogen cycle. He's treating his aquarium like a continuous environmental monitoring system.
And his photography isn't just pointing and shooting. He's noting the variables, the aperture, the ISO, the lighting conditions, the post-processing steps.
He treats his garden like a huge open source project. And when a component failed, the red ivy, he didn't just delete the code.
He opened a ticket. He documented the failure mode, which was the patchiness. He checked the dependencies, light, nutrients. And he consulted the existing documentation, all 755 previous parts of it.
The point isn't that tech people can be good gardeners. The point is that the underlying skill, that relentless methodical search for cause and effect, is a kind of superpower.
You can apply it anywhere. You can use it to achieve mastery in any field you choose.
Which leaves us with a final thought for you, something to chew on after this is over. What unlikely area of your life, what passion could you transform by applying the same systematic rigor you use in your professional life?
What could you master if you treated it like Eng, the old software plumber, treats his garden? The systems thinking you already have is portable, so go apply it to something beautiful.
Go find your own Strobilanthes and start documenting the bugs.
A perfect place to end. Thanks for joining us for this deep dive.
My pleasure.